In this video, we are going to see about Regula Falsi Method. It is also known as false position method. It is a numerical technique which we use to find out the root of a continuous function. Okay, it is similar to bisection method. If you want to know what is bisection method, the link of the bisection method I'll give in the description of this video. You can go through it. So the difference between bisection and regular falsi is that regular falsi method converges faster. Converge means it gets to the optimal solution faster. So here it iteratively improves an estimation of the root by using a linear interpolation between 2 points where the function sign changes. So basically here linear interpolation method is used. In the bisection method we use the middle point. Here we are using the linear interpolation. And one more thing, here it is given that the function sign should be different. So if a function f of x is continuous in the interval a b and fe have opposite signs, then there is at least one root in that interval. So if we need to explain this, you see, this is an continuous function. So a and b are supposed the roots of this. We take the interval a and b. So if f of a is positive and f of b is negative, so definitely there will be a root between a and b. That's why the sign of a and b should be different. So that is what is given here in Regula Falsi method by this line. So first, these are the steps of the Regula Falsi method. So first, we are going to choose two initial points a and b, okay, such that the intervals f of a and f of b have opposite signs. That is the value that we will obtain when we will put a in the function. That value and this value should have opposite signs. I have already told you why they should have opposite signs. It will mean that there will be a root in between the points a and b. Then we are going to compute the approximation of root x of n using the Regula Falsi formula. So this is the formula. X of n is equal to a of f of b minus b into f of a divided by f of b minus f of a. Okay, so this is the formula. So after applying the formula, we will get the value of x of n. So now we will check if f of x of n is close enough to 0 or the tolerance value. If it is close to the tolerance value or less than the tolerance value, we are going to stop. Otherwise, we will have to set new intervals. What is the new intervals? As I have told, if f of a and b have opposite signs, it means what? Suppose f of a is positive, f of b is negative. It means if we multiply them, we will get a value less than 0. So in order for a and b to be intervals, then f of a into f of b should be less than 0. Similarly, if f of a into f of x of n is less than 0, it means what? The root lies between a and x of n. It means we need to change the value of b. So the value of b will be x of n. Similarly, if f of b into f of x in less than 0, it means the interval lies between b and x of n. So we will have to change the value of a because b is same a value. So we will going to make a equal to x of n. So we will repeat this process until convergence is reached. Convergence means some optimal solution. So here we will say we will give the number of iterations. Okay, we will give some set of iterations. So until then, if we get the value, it's fine, that is close to 0. Otherwise, there is no roots available. Let's try to solve it using example. So here we are having the equation fx equal to x cube minus x minus 1. So we will try to find the root of this equation by using Regula Falsi method. So the first thing is to find the two initial points a and b, okay, such that f of a into f of b is less than 0. That is, they have opposite signs. So let us take a equal to 1, b equal to 2. Now if f of 1, we find out 1 cube minus, that is, we are going to put the value of 1 in this equation. So it is 1 cube minus 1 is equal to minus 1. Now we will find f of 2. So we will put the value 2 in this equation. So it is 2 cube minus 2 minus 1, which is 5. Now you see both are having opposite signs, that is f of 1 into f of 2 is less than 0. So it means that there is a root that exists between 1 and 2. So we can proceed to the next steps. Okay, so next we are going to try to find out the value of c. So here if you see, I have already given in the formula itself. So this is the formula, like x of n equal to a into f of b minus b into f of a divided by f of b into f of a minus f of a. So here we will just, in place of xn, I am writing c variable. Okay, so here we will put it in this formula. What is the value of a? It is 1. What is the value of f of b? We got it as f of b, that is we got it as 5, right? So we are going to put 5 here minus b. B we took as 2. And what is f of a? F of a we got minus 1. Okay, so put it in the formula. So what we got? 1.1667. This is the value of c. Now we will try to find f of c. So f of c is equal to, we will put this value 1.167 in the equation. What is the equation we were using? X cube minus x minus 1. So 1.667 cube minus 1.66 minus 1. So what is the value we got? Minus 0.578. Now we will see whether it is negative plus it is not equal to 0, or it is not less than the tolerance value. Okay, so we are going to go for the next round. So now this is negative. Whose value was positive? F of b's values was positive. So f of b into f of c is less than 0. So the new interval lies between b and c. That is, we are going to change the value of a. So a will be this value, this c value. Okay, so a is equal to 1.1667. So the new interval is a is 1.1667 and b is same. B value is 2. So 2 and 1.667, the new interval lies. So again we are going to go for the second iteration. Then we will again check the value of f of c. So till the value of f of c becomes less than the tolerance value, we will keep on going through the iterations. Now how many iterations we will go? We can give the number of iterations that we want to do. Okay, that's all for today's video. So here we saw the algorithm for Regula Falsi along with one example. Okay, in the next video we will see how we can implement this Regula Falsi using C++ programming. Thank you.